At this very moment, I'm writing one of the most complex programs I've ever written with no hands. I'm going to build a cascading prompt management system where each choice you make filters the next selection. In the first version of the prompt manager, I asked Claude Sonnet to build it test first. And it was very excited to do that and said, this is how I like to do this. And afterwards told me how it was able to gain insights from doing TDD that it might not otherwise have gotten. And that affected the quality of the code. This is why I'm a proponent of doing TDD and why we humans get benefit from it. So it was really good to see the AI got benefit from it as well. So I'm proposing now that we build incrementally through emergent design the next phase, this data-driven phase. And it's so interesting because this is a really hard and challenging program. This is one of the toughest ones that I've encountered, really. Not because it's a hard problem, but because it's recursive. It has an elegant solution, I think. And we just have to discover it. But there's a lot of complexity in it as well. So we're building this out together and we're building it incrementally. We're merging the design. And I asked Claude Sonnet to do this for the same reason that I'm asking it to do TDD, which is that we discover along the way the best designs to use. And this is a technique that really informs me when I build software. And I've seen it inform a lot of other people when I taught it to them. And so I'm interested to see if it informs the AI like it informs us, like it informed the AI when we did test-driven development together. Okay, I'm in the program and I want to show you a quick demo. This was mostly built in our last episode. I did a few enhancements since then. It asked me if I wanted to do the next stage, and I thought that was just cleaning up the tests, and it meant building the next subsystem. So before I knew it, a whole bunch of other stuff was built. And so you're kind of in the middle, so you're seeing where the exciting parts are. Here's my prompt template test. This is all in Python, fairly straightforward stuff. And you can see it's setting up the tests. These are PyTest tests. One of the things that we're going to do is refactor not all of our tests, but many of our PyTests, all the tests that are dependent on the dynamic stuff. We're going to refactor that using a tool called approvals tests. Because when you look through the test, you'll see enormous amounts of redundancy in our unit tests. It's fine for the program itself, but remember this is all data-driven. So the data-driven component needs a dynamic way to generate verification, just like it's a dynamic way of generating the actual information itself. And there's a perfect tool for that. It's called approvals tests. By the way, talk the creator of approvals tests into making a little demo video for us on how to use it. So that video is somewhere up here. So check that out if you want to know how to use it. It's really handy and why to use it. I'm a big fan of unit testing, test-first development, and this is a tool that is perfectly in alignment with it. It works slightly differently. It's good for when you have really complex testing or complex outputs that you need to verify, but it still upholds all the principles and all the benefits that you get from doing test-first development. Here's my prompt builder class. We have different pieces of prompts that we saw, the different components in the demos, like you saw, like the role and the what and the why. So those are examples of different pieces. And this is just a basic object that's getting all the elements. Here's the prompt builder. It has a very large constructor. And oh, this is great. It passed in. I wanted it to include other information, and I didn't tell it what. But once again, it read my mind. So this is the kind of stuff, which model to use, what the temperature tokens you want to use, exactly what I wanted. Very good. I think we discussed it at some point. I'm finding, the AI behind Cursor right now that I'm using is Claude Sonnet. I'm very pleased. I'm actually very blown away because it's so good. And here is we have a prompt validator class that basically is involved in making sure the prompt is well formed and the name is well formed, etc. Search services, we have a parser for the template. And this should be, and is, very nice, generating those combo boxes dynamically. That's what I wanted it to do. So that's good. It makes a lot of sense to do that up front, so that's what it did. Let's see what else we got. So here's our data. And here's our different components. And here's our pieces of our prompts. Here's my base class. This is all of our templates. And we have a lot of templates. The basic prompt manager has the basic CRUD operations. As you see here, here's what a prompt object looks like. Here's my backing storage. I'm just using JSON files. Very, very simple, but it works. And here is my web interface. This is the UI, and it's all Flask. I don't know Flask. It wrote all this for me. It did a pretty good job. Here we have templates, and we're going to build those out later, but here's our simple index template. We have a lot more templates that we'll be building as we build out new different prompt types. Here's all of our tests, and we have a lot of tests. It'd be very interesting to see when we refactor this code, which tests support the refactorings and which tests break. It's not as important as when humans are working on it because breaking tests kind of freak people out, but I think the AI is okay with it and knows how to rewrite them and all. So it's not so much a big deal. But I do like to know whenever behavior changes. And those kinds of tests, the test against behavior, those are the ones that we want to keep an eye on. All right, we're back in the template builder. We want to be able to work with templates, save them, and also be able to modify them. So right now, here's an example of a template. As a role, I want to what so that I can why. When I hit generate, it's going to create combo boxes for each one of these different tags. And I should be able to edit them. Now, we're not actually able to edit them, so that's one of the things that we're going to fix. Also, we need to be able to dynamically create as many of them as we want. And there's a relationship, there's a linkage between them. So when I select something in one of the first combo box, it's going to change what happens in the other ones. So all of that requires a fair amount of code behind to make it work right. And that's what we're going to be working on. Okay, we've looked at some code. I've showed you how the current version works. I'm going to refactor this with Cursor. And in my experience, it happens so fast, we might miss it. But I'll be back to show you the refactored code and the new behavior and why I think it's better than the way the system works now. So we do everything test first, and we're emerging this design. And as I'm speaking in the background on this very machine, it's building it all out for us. This is what programming looks like in the future, guys.